Welcome to the shop. I'm continuing work on the multi-axis hot glass squeezer release candidate 1, and I'm out in the lathe room right now. I don't usually do videos in the lathe room, so I have a kind of a inconvenient setup here with the tripod and the GoPro, and probably one of these days I'm gonna come up with a less obtrusive camera mounting, because it does kind of get in my way when I'm working, but hey, it's good enough for right now. Close enough is good enough. So today I'm making idler sprockets for small roller chain. And you might ask, well, why don't you just go to McMaster and buy them? Well, I looked and I looked and I looked and I looked, and the idler sprockets that I want are really small, and they're really thin, and they don't have a hub, and they fit into a really tight area, and I just couldn't find anything close. And you know, when you have a CNC machine shop, it's not that hard to make things. So I'm starting out here on the manual lathe with a piece of 1-inch brass bar stock, and I'm going to be cutting some blanks. So, using a carbide insert parting tool here, and in the past I've had a lot of problems with parting. I don't know, maybe it's just because I don't know what I'm doing, or maybe it's just because parting is inherently difficult. I think somebody on one machinist group said, to kind of quote Shakespeare in a non-traditional way, parting is such sweet sorrow. So anyway, I just finished a cut, so the tool is on the face of the cut here. I'm going to set the DRO for 0, and then I'm going to move the distance that I want over here, plus the size of the tool, so I get the thickness of the part that I want. And then I'm going to drill. I've got my drill oriented in such a way that the flutes kind of have, that I'm not going to run the tool into the flute, because I'm going to leave the drill in the hole to catch the cutoff, because I don't want it flying. So I'm going to drill the hole, have the flutes aligned in such a way that the parting tool can actually have some clearance, and then part off a part. I'm not going to partly part a part, I'm going to fully partly part a part, and maybe fart. Boy, that brass cut's nice. Just feeding by hand. No problem at all parting the brass. I've had lots of problems in the past parting other materials, mostly because of chip clearance. And there we go. So, over to my caliper here and verify that, oh yeah, I'm looking for 120 and it's 119.5, so I'm going to call that good enough. And I'm also going to turn off the camera and then set up over at the mini mill. I've already got a tooling plate made, and then I'll cut the idler sprocket teeth on the mini mill. So, see you later. I'm out at the mini mill now, and I thought it might be slightly informative to show how I deal with my soft jaws and how I deal with the adjustment and alignment of them. For most of the work that I do, I use soft aluminum jaws with a ledge machined into them. I don't know if it shows up on the camera, but I have engraved into the top the size of the ledge. So this is a 200 by 150, and for this operation I'd like to use my 300 by 150. So I'm going to go over here get Mr. Electric Tool, open the vise up, then get another electric tool, because I like electric tools. I definitely don't like having to use a regular old school hex key to take jaws out. I mean, that's annoying. So, out with the old. And wipe, and wipe. And yes, you can see why I use soft jaws. Well, you can make a mistake and not booger up your vise. And the other thing that you may notice is all of the various different drill bit divots that a lot of times when I'm drilling a hole, the hole is fairly close to the edge of a part, and I certainly don't want to run my drill bit into either the vise or my parallels. And the nice thing about the aluminum soft jaws, I can make a little drill divot like that, and it doesn't affect the holding precision at all. So I'm gonna put these guys get some serious inscruzolation here, and then just make sure they're where they need to be. So I've got programs that I've written for probing, and for many of the parts that I do, and no, I don't tighten the vise with the electric impact tool. I tighten the vise by hand because I don't want to break my vise, but when I'm doing rapids, I do use the tool. So I'm going to put my 1, 2, 3 block, and I actually found a 1, 2, 3 block that had no holes in it. And yes, this is precision. I measured it with a nice micrometer. And for many operations, I define my Z0 as the surface of the ledge. For this operation, the Z0, the part that I'm going to be making, the Z0 will be on the top of the part, but I still run the same setup program that probes the top and the sides because it's fast and easy, and it kind of guarantees that I'm not going to hurt the probe, because before it tries to probe the sides, it knows where the top is. So, probing, work offset 1, XYZ 1, 2, 3 block. And I'm looking up here at my comment probe, XYZ corner of 1, 2, 3 block, G54. Even though I've run this thing a zillion times, I still put it in 25% rapid because, you know, that's an expensive probe. And for those that don't know, the white piece that is protruding out of the probe is intended to be breakable. It's kind of like if you really screw up, well, you break the white piece and you don't destroy the expensive part up above. Of course, if you really screw up, you destroy the expensive part up above, but it's designed to be a sacrificial replaceable piece. So now I've got the, let me take the 1, 2, 3 block out. I've got the XYZ 0 set down there. Of course, I don't want the Z0 set there. I want to do it. I'm going to be making a tooling plate, And I always like machine off on the sander a kind of a crude but useful little chamfer that tells me where 0 is, and then tighten by hand. So now with the probe in place, I can jog over and then load my Z probing routine. As I said in previous videos, the VPS templates that are set up for probing do not set the correct tool offset for the length of the probe. And if you tried to run the probing cycle without doing that, if you just stuck the tool in by hand, well, you'd end up in a very unhappy place. I think actually, now that I think about it, I believe that the Renishaw macro actually will flag an error, because I think it has stashed away somewhere the what it thinks the tool offset is, and so it may actually save you from making that mistake. But that's why I use my pre-programmed programs for doing my probing. So now that I've got the tooling plate in place, I'm going to drill a hole and tap a hole. And I know it's not very exciting, but you know, even the not very exciting things need to be done. So, standard procedure. Going over to distance to go. Got the option stop turned on. Looking at the tool, looking at the offset number, and remember that on this machine, tool number does not equal offset number. So 25% rapid, single block. Stopping at a reasonable place. $10,000 RPM, fast pack. Going to be doing a 1/4-20 tap at 500 RPM. And boy, I love power tapping. Entirely reasonable. Distance to go. All is well. And there we have it. So now I think I'll go ahead. The part that I'm making is the Z0 reference is going to be at the surface of the tooling plate, so my Z0 is set up properly, so I can go directly to making my part. And before I actually mount a blank, I'm just going to run the thing, make sure it works okay, and it should just barely kiss 10 thousandths off the top of the tooling plate, kind of letting me know that all is well and it's working correctly. So starting off, tool number 1, tool offset number 1, 1/4 inch end mill, single block, 25% over into position. Looking sane, distance to go. 10,000 RPM. And no, that is not correct. It didn't ruin my part. My tooling plate will survive and be useful, but that is actually an error. So it's now off to the CAD room. It's, yeah. I hate making mistakes, but at least this one is a mistake that isn't a mistake. Let's try that one again. Hydraulically inspect, and yes, it is correct. Had the 0 set in the wrong place. As much as I hate making mistakes, my favorite kind of mistake is one that doesn't matter, that doesn't destroy my part. So let me go ahead and run this thing and just make sure that I've got all the clearances I need. I'm going to have a mounting screw at the top, and I want to make sure that I don't hit it with the rapids. I don't believe that'll be a problem. That's not a problem at all. Probably going to have to put a different tool in for okay. Using a different tool set with my correspondence between tool number and offset number, so I kind of have to manage that more or less by hand. When I'm doing production, I've got everything preloaded and pre-staged, but for prototyping, I have to be very careful. Look at the comment, think about what's going on, look at the tool, and adjust if necessary. So this is an 1/8 inch cutter, and it's intentionally going really slow because I don't want to break my 1/8 inch cutter. So I bet I can speed it up, and I probably will speed it up, but like I said in previous videos, the first step in the process is always just get the tool path to work successfully, and then depending on how many objects need to be produced, optimize later. I'm using a washer to hold the blank in place so the socket screw doesn't booger it up. So let's give this thing a try. See if we can make this pig oink. Finger on the stop button just in case. Yeah, that does not sound scary. I'll probably bump the feed up a little bit. That's 10 inches per minute is an insanely slow feed, especially since the cutter is not cutting into a blind slot. It's got plenty of chip evacuation. And there we have it. Let me see if I can get some sort of a... So that is our little part. And then the next step, I'm going to put this on a little arbor on a hand drill and just kind of like knock the burrs off and round it off a little on the Scotch-Brite. But there we have a nice little brass idler. So I'm going to run the batch and then set up and make another part. A lot of the parts for the multi-axis squeezer aren't really that interesting. I've made a couple of them off camera because it's just more of the same old thing, or since I like acronyms, Motsat. A lot of them are just Motsat. And so, and who knows, maybe a lot of you like watching Motsat and you're wondering, hey, why don't you show more Motsat? Well, I don't know. Maybe I will, maybe I won't. It's not exactly zero effort to make these videos, so, you know, sometimes I just get lazy and go, hey, I'll just make a part. So anyway, turn the camera off and back later for another part that isn't that exciting. Well, after that nice long rant about Motsat, here's some Motsat. These are pretty uninteresting parts, and, you know, they're parts. Parts is parts. The blanks are cut to length on the table saw, and as I've said before, the table saw can be surprisingly accurate. I can actually get within a few thousandths, easily within 10, often within 5. And the length and perpendicularity and surface finish really aren't that important because all of the critical locating stuff is drilled and milled on the part, and so the edges, they're basically just cosmetic anyway. So I'm going to need to probe, because, let me get that program, select program. I'm going to need to probe the top surface because I'm referencing Z0 from the top surface. So now I've loaded the probe, set the proper tool offset. I don't have an automated routine for this because, you know, every part is different. So I do have an automated routine that selects the tool and applies the correct offset, but then I have to remember to change into the right mode and probe. So there we are. Now, hopefully this will work the first time. This is a pretty darn simple program, but hey, even the simple ones can be a problem. So, typical procedure, option stop. Gonna be doing some roughing here, and actually not, I mean, there won't be any finish operation, so the rough is the finish, but I'm a little bit a little bit uncertain about exactly how to properly construct a tool path for this operation. And when I say properly, I'm talking about optimizing for the highest production. In Bobcad, which is the software that I use, it doesn't allow high-speed machining unless you start with a solid model. And, well, I didn't feel like creating a solid model of this, and it's just a 2D sketch. And so I can't really use high-speed machining on a profile starting from a 2D drawing. I can do a kind of like what they call adaptive roughing, which I think is roughly the same as high-speed machining. I can do that on a pocket, and well, I'm not really cutting a pocket, so I'm not sure I'm going to like this tool path, but I'm fairly sure it'll work. So if I go into production, I'll probably take some time to optimize this to really make it good. But for right now, hey, close enough is good enough, or so I hope. So, 25%, looking at everything just to make sure all is well. Got my number 4 tool, which is tool 4, tool offset 4, 10,000 RPM, 3 flute Lakeshore carbide, zirconium nitride coated, special for aluminum cutter. And let's see if we can make this pig oink. "90 inches per minute." Being kind of conservative about this. Going to be making the cut in 3 passes, although I suspect I could possibly do it in 1 pass. But this is typical for the way that I approach machining. I typically start conservative, get a part made, and then if I go into production, depending, if I'm making 2, well, that's a different question than if I'm making 100. And if I'm making 100, I really try really hard to get it optimized. If I'm making 2, oh well, close enough is good enough. Now I'm doing another cutout on the other side. This is a little clearance cutout to make room for the return spring. So that all went well. Gonna drill some holes. Check the stick out to make sure it's okay. Number 28, single block. I'm thinking I'm okay. Not sure the tap is going to be okay. I may have to always, in a situation like this, it's always a tiny bit nervous because I use the short drills, I use the screw machine length stubby drills, and I do that for rigidity so that I don't have to worry about. Okay, so that's somewhat unexpected there, that it is going to the drill and not to the tap. It may be perfectly fine. I use the screw machine length stubby drills for rigidity. If I don't need a lot of stick out, I don't use a lot of stick out, and this means that I can get, the acceptable accuracy that I need without a center hole, a pilot hole, whatever, a spot drill. If I really care about accuracy, or if I'm doing a deep hole, or if I have anything that requires long stick out, I'll use a center drill or a spot drill. But for this application, stubbies are fine. Just got to be careful of that stick out. It is a 1-inch thick piece of material. So this is looking good. 10,000 RPM using a fast pec cycle. And there's my tap. Looks good to the eyeball. Yes. Boy. I don't know. I'm gonna go to the CAD room and check that. Nope. That would not work. So I think I'm gonna change my strategy here. The part needs to be flipped. I need to make a cut on the other side, and I'll go ahead and tap on the other side. I just don't like that amount of stick out. So I'm designing as I'm going. So back to the CAD room, gonna redo the toolpath. So yeah, I think it'll be better overall to drill and tap that one from the other side. So this one will still be okay. The part's perfectly fine. Yeah, it'll be a good part. Okay, finger on the stop button. Mostly very low spindle horsepower, sometimes getting up to 60%, but most often in the 20–30%. So I'm pretty sure that I could be more aggressive with this, but when I finally go into production, I may just go ahead and use the solid model and do the adaptive roughing that comes in from the outside instead of plunging in from the center. Okay, well, I'm going to run the rest of the batch. This is not a big batch. I'm only making 8 parts. So I'm going to turn the camera off, run the batch, make the next tool path, and then finish up this not very interesting but certainly necessary part. Okay, so first operation performed successfully. Not sure I like the tool path for this cutout. The parts are fine, they'll work just fine, but when I go into production, I'll probably do a different tool path. So, I'm going to flip the part and do the other side. Still referencing from the same face, so my 0 is independent of my length. Even if my length was a little bit off, things are still lined up because I'm zeroing from the same face. So, new program. Standard operating procedure for a new program. Option stop, tool 28, tool 28. Even though I know for sure I'm okay, I just do the drill every time. I hate making mistakes, and I make a lot of them. I think just a moment to talk a little bit about philosophy. There are certain things like watercolor painting or certain types of manual machining where you get one chance to do it right, and if you do it wrong, well, you may have destroyed your entire project, wasted several hours or weeks even. And I tend to not be good at those kind of things. My background is in software, and in software you have a bug, well, oh well, you go back, you fix it, you run it again, still got the bug, you go back and fix it. It's an incremental improvement scheme where you continue to peck away at it, and every time you make a little change, you can move toward completion and toward perfection. And that's why I like CNC machining. It's very much like writing software, where, oh, you first, the first version of the tool path, well, it wasn't quite that good, or if you're really unlucky, you crash the machine, you break a cutter, you ruin a part, oh well, go back, try again, and at the end of the exercise, really good parts are always produced. And, you know, I have tremendous respect for those manual machinists who can just go out to the machine and step by step, never make a mistake, and, you know, very, very long process, maybe a week-long process of paying attention and doing every step right on a, you know, multi-thousand, possibly $1,000,000 part. And boy, I've got a tremendous lot of respect for those guys, but that ain't me. I do what I do. This is what I do. Distance to go looks good. All looks well. Take it off single block. I'm much happier drilling from this side. Now, if it was ultra important, where I had to guarantee that those holes were like within a half a thousandth from that face, I might do it differently, but for this, the face is just clearance. Single block, 25% rapid, looking good. Distance to go, take it off to single block. Tappy, 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 no stick out problem at all. And then gonna cut the relief on the other side with the 1/2-inch cutter. Cutter number 4, tool 4, single block. Doing it in 2 passes, 1/4 inch per pass. And it looks good. So there's the part. A little burr on it, but yeah. There's the part. Nice heavy part. I want this part to be strong. So 1 inch thick aluminum should be strong enough. So I'm going to run the batch and then go over to the assembly bench and give a little tour of how the pieces fit together. So see you later. So here's today's progress. The sliding pieces are sliding nicely, and they all line up oh so precisely. Oh, I just love precision work. And today's little sprocket fits into its little chain. And then this is a part that I made off camera. Probably should have shot it, but oh well. It's a slightly kind of interesting part. And then when this is assembled, this little guy like that is going to have a little steel shaft, so you got brass running over steel. And then the chain will run over the little idler like that. And then these little guys will go in that position, and the chain pulls the sliders. So that's it for today. Thank you for watching. It's been fun.